Welcome my students and my valued viewers. Today I will finish this Cobb-Douglas production function. In the last class I took up this Cobb-Douglas production function, and in last class I explained 6 properties of Cobb-Douglas. Remaining 6 properties will be explained in just today's class. So today's class is just in continuance of the last class or the previous class. So in today, the 7th properties of Cobb-Douglas says that the marginal product of the factors are directly proportional to their average products. These two factors, K and L, the marginal product of these two factors are very much dependent upon their average products. Now, come on. Marginal product of the capital is delta Q by delta K. So this is the first order partial derivative of this original production function. This has been the differentiation with respect to K. Now by slightly rearranging, we keep alpha here and a k to the power alpha minus 1. So minus 1, k to the power minus 1, this is brought in the denominator. So numerator we have a k alpha L beta, it becomes Q. So alpha into Q by K. And this Q by K is the average product of the capital, so alpha into APK. So absolutely MPK has become the function of APK. Now marginal product of labor, Q is differentiated with respect to L, beta AK alpha L beta minus 1. Once again, this L minus 1 is being brought in the denominator. Now we have beta AK alpha L beta by L. This is beta, this becomes Q, once again Q by L, this is average product of L. So absolutely this has become the function of APL. So we say that in the Cobb-Douglas production function, marginal products of the factors are directly proportional to their average products. Now 8th property, expansion path. Expansion path of CD production function is linear and passes through origin. This is the shape of the, now we have the different cost lines. The producer has different cost structures, and at different cost structures there is a different point of equilibria. Now if those equilibria points are being joined by a line, we get the expansion path, and this expansion path could be of any shape. It may arise from origin, may not arise. It may be linear, may not be linear. So in this Cobb-Douglas, this line or the called expansion path is linear and passes through origin. Now mathematically, if any line originates from origin and slopes upward, then it could be expressed as ax minus by 0 or ay minus bx is 0. Expansion path will be of the same mathematical form. Now these all points are point of equilibrium. So expansion, for just finding expansion path, we take the equilibrium condition, that is MPL by MPK is PL by PK. This is MPL, this is MPK equals PL by PK. This is solved. K is taken in the numerator, L is brought in the denominator. Here PL by PK. Now in just numerator we have beta K, denominator alpha L. So beta K by alpha L equals PL by PK. Now by cross multiplication we have alpha PLL equals beta PKK. Now both are brought together, so alpha PL into L minus beta PK into K is 0. Standard form, this is constant and this is constant. So this expansion path gives us the linear as well as it just passes through the origin. Now come on the 8th property. 8th property is Euler's theorem. Euler's theorem explains the distribution of output among the factor inputs. This is one of the important property of Cobb-Douglas. It says this is called Euler's theorem. This is Euler's theorem. Mathematically, this could be expressed as K into MPK plus L into MPL is Q. This is total payment to capital. This is just total payment to labor, and the sum of these two payments to these two factors equals total product. So there is no profit or zero profit. Now LHS K, and this is delta Q by delta K plus L delta Q by delta L K alpha, a K alpha minus 1 L to the power beta plus beta L a K alpha L beta minus 1. Now this K is absorbed here. Alpha minus 1, K will go there, minus 1 will disappear. So alpha a K alpha L beta, here beta is taken to there. So L is absorbed here. So beta and a K alpha L beta. Now from bottom this could be taken outside as a common. So a K alpha L beta, alpha plus beta, and this is Q. And by assumption in Cobb-Douglas we have alpha plus beta equals 1. So 1, and that is Q, and this is RHS, right? Now from this property, two important corollary comes out. Under constant returns to a scale, when the factors are paid according to their marginal products, there is no profit or zero profit. Now let us see what happens when there is increasing returns to a scale. And factors are paid equal to their marginal products. So there is very disturbing outcome. There will be loss. Here was the constant returns to a scale. Now if we come to the point that there is increasing returns to a scale in the production and factors are paid equal to their marginal products, then what will happen? Though initially it looks very rosy picture that, well, producers are producing an increasing returns to a scale, but if the factors are paid according to their marginal products, producer will land itself in a state of loss. Now it could be shown, let Q is a K square LQ. Now this production function shows increasing returns to a scale because degree of homogeneity is 5 greater than 1. That's why diminishing returns to a scale. Now let us see what happens when the factors are paid according to their marginal products. So K into MPK plus L into MPL. Now K to A K LQ plus L 3 A K square L square. Now this K goes there, this L goes there. So what happens? 2 A K square L cube plus 3 A K square L cube. A K square L cube could be taken as a common. So we have 2 plus 3. This is Q and this is 5. So it has become 5Q. So total cost is 5Q, much greater than the total product, and so it is loss. And the third corollary says there is diminishing returns to a scale. There is diminishing returns to a scale and factors are paid according to your marginal products, only then producers will be in absolute profit. Now for this, we may take the production function as a k to the power 4 L to the power 0.3. Now here degree of homogeneity becomes 0.7 and this is less than 1, so diminishing returns. Now let us see what happens regarding cost. So K and its differentiation. So 0.4 A k to the power 0.4 minus 1 L to the power 0.3 plus 0.3 into L into A k to the power 0.4 and L to the power 0.3 minus 1. Now this is 0.4 and K A k to the power minus 0.6 L to the power 0.3 and 0.3 L A k to the power 0.4 and L to the power minus 0.7. Now this K should be absorbed here and L should go there. So what happens? 0.4 A k to the power minus 0.6 plus 1 L to the power 0.3 plus 0.3 A k to the power 0.4 and L to the power minus 0.7 and plus 1. So is this 0.4 A k to the power 0.4 L to the power 0.3, 0.3 A k to the power 0.4 L to the power 0.3. This term could be taken outside. So A k to the power 0.4 L to the power 0.3, 0.4 plus 0.3. This is Q and this is 0.7. So 0.7 Q is absolutely less than Q. And this takes the producer in a state of profit. Yes, so this was the implications of Euler's theorem in case of Cobb-Douglas as well as elsewhere. So this is property 8. Now, property 9, of substitution. Necessity of substitution of Cobb-Douglas, which happens to be unity. Now come on property 10, that is elasticity of substitution. Now just come to the theoretical side. Elasticity of substitution measures the ease or comfort at which factors could be substituted among each other. So this measures that, and it is different for different shapes of isoquant. If isoquant is linear, of course, it's rare and non-practical, but it is feasible theoretically that if happens to be IQ happens to be linear, then it shows perfect substitution between K and L. Even production could take place at this point. Here K fully substitutes L, or producer could substitute at this point where labor fully substitutes K. So in this case, elasticity of substitution is infinity. Just reverse case, when IQ happens to be right angled or Leontief isoquant, this is called Leontief isoquant. This is right angle, and on this isoquant there is one and only one technically feasible point where production could take place. So there is a unique combination of K and L at which production takes place. Producer cannot move in either directions, so there is no chance of any substitution between K and L. So substitution, elastic substitution becomes 0. And most practical case is when there is a convex isoquant. So if consumer moves from point A to B, producer, what is happening? This much of capital has substituted this much of labor has substituted this much of capital Or conversely, if producer moves from point B to point A, then this capital is substituting this amount of labor. So there is limited substitution. Limited substitution, and we are concerned with this type of production function, which just corresponds to Cobb-Douglas. Now, in the case of Cobb-Douglas production function, elasticity of substitution is 1. Now, for finding elasticity of substitution, this formula could be used. It is Fk into Fl divided by Q into Fkl. Now, this is first order partial derivative with respect to K. This is derivative with respect to L. This is original production function, and this is cross partial derivative. That is derivation of this Fk. That becomes Fkl. Now, entire total terms of numerator or denominator will just cancel numerator. So 2a gets cancelled. Alpha beta, k alpha minus 1, L beta, k alpha, and L beta 1, and that comes to 1. Now, this unitary elasticity of substitution means theoretically that whatever be the level of production for this Cobb-Douglas, the factor ratio K by L or L by K remains constant for each and every level of production. Now, property number 11, this is total factor productivity. This property relates to growth economics, and this total factor productivity name was given by Solow. Elsewhere, this has been called as residual. This says that growth in Q is dependent upon the growth of K, growth of L, and this A denotes total factor productivity. That is the growth on account of the factors which are not included in the model. So this A becomes total factor productivity. So the growth relation between Q, A, K and L could be expressed as delta Q by Q. This is rate of growth of output. Now, this alpha is the share of capital in output alpha, and into rate of growth of capital, plus beta into rate of growth of labor, plus this is total factor productivity. This we are supposed to find out. This is taken to left side. So total factor productivity is rate of growth of output minus sum of the growth on account of capital and labor. So by this formula, we just calculate total factor productivity. Now, we may solve one smaller sum on this, which has been asked in net. Just I am solving this sum. Now, this sum was asked in net exam a couple of years back. This sum says that in a CD production function, output grows at 6%, labor and capital grows by 3% and 6%. The capital and labor elasticities are 1 by 3 and 2 by 3. Of course, these are the share of labor and capital in the output because both are equal. Find total factor productivity. Now, this is the formula for total factor productivity. Delta A by A, this is total factor productivity, equals rate of growth of output minus sum total of growth of capital and labor. This is the capital elasticity or share of capital in the output into growth of capital plus labor elasticity or share of labor in the output into growth of labor. Now, everything we have given. This growth in output is 6%. Now, minus share of capital is 1 by 3 and capital grows by 6%, plus share of labor is 2 by 3 and labor grows by 3%, and if we solve it, this becomes 6 minus 4%, that is so. This 2% is total factor productivity, and I had explained in the last class that total factor productivity, let this is maximum output. enhancement of A, if the value of A has increased from A1 to A2, this has pulled up the production function upside, and even if the labor quantity remains constant at L1, we have greater output, because previously we had this was total output and now it has increased from Q1 to Q2. So this is the effect of total factor productivity. Now finally, and the last property is neutral technical progress or disembodied technical progress. Through Cobb-Douglas production function, we can measure neutral technical progress, which is alternatively called as disembodied growth. Now, for incorporating rate of growth, this model has to be expressed in this way: e to the power mt, where the t is the trend factor or time, or m is neutral technical progress or disembodied rate of growth. This m has to be calculated. Now, to make this function linear, we take log both sides. This is taken log. Now we differentiate the entire function with respect to t. So this is 1 by q dq by dt. This is just differentiation with respect to L, and this is differentiation with respect to K, L, and this is MT, MT का differentiation, here is M. Now we have to find this M, so this whole portion has to be substituted, just subtracted from this one. So M is this minus this one. So this is the measure of neutral or disembodied rate of growth in Cobb-Douglas production function. By this way, I come to the end of this Cobb-Douglas production function. I have explained almost all the properties of Cobb-Douglas. Just closely related to this production function is CES production function, which I shall be explaining in another video in rather greater detail. I shall do it. Let it be this Cobb-Douglas, and from next class, I will start a class of OR, Operation Research, and this is all for today. Thanks.